I'm doing some grade 12 work with you in grade 11.
In this grade 12?
Water, yes. Water automatically ionizes to form hydrogen ions and hydroxide ions. And at 25 degrees Celsius, they find that the concentration of the hydrogen ions is 10 to the minus 7 mole per cubic decimeter. What will the concentration of the hydroxide ions be?
10 to the minus 7.
It will be the same, 10 to the minus 7 mole per cubic decimeter. Alright?
Yes.
Now there is something called the ionization product or ionization constant. And where this comes from, you will understand after we've done reversible reactions next year. Okay? It's called the KW. And it is determined by the product of the concentrations of the ions. So please don't stress about this and say, I don't understand. Okay? You will understand. Okay? So the KW for water is the concentration of the hydrogen ions times the concentration of the hydroxide ions. So what is 10 to the minus 7 times 10 to the minus 7? Yes, 10 to the minus 7 squared. It is 10 to the minus 14. Now in grade 12, you will learn that this value is a very small value. It's much smaller than 1. And the significance is that the concentrations of ions is very, very, very low. Very low concentration of ions. You'll understand later. Just allow it's a reversible reaction. Can you see? Okay. So the amount of this and this is very small. And you can see it from the value there. The amount is very small. Alright? Okay. So most of water will be H2O. Very little of water will be H plus and OH negative. Very small percentage will be that. Okay. Why am I explaining this to you? Because this is where pH is coming from. pH is the measure of how much hydrogen ions are placed into the solution.
In this reaction, what is a weak base?
No, don't ask that question now.
Am I correct?
Okay, I'm going to, no, don't ask that question. Alright? I want to go to pH now. So, I'll write it down. It's called the ionization constant or the ionization product of water. It comes from, the KW comes from multiplying the concentration of the hydrogen ions by the concentration of the hydroxide ions, and it's simple mathematics. You get to 10 to the minus 14. The significance of it is that it shows you that there is very little hydrogen ion and hydroxide ion in the solution or in the mixture. Okay, I want to continue.
concentration of water in power.
Okay. So pH is the measure of how much hydrogen ions are present. And the mathematical relationship between concentration of hydrogen ions and pH is this.
No.
That's why it's grade 12, because we only learn logarithms next year.
Yeah, but it's not difficult because your Casio's got the function on
I
the...
don't know what it does though.
It raises something to the power 10.
Negative log.
Because the opposite, this opposite of the log is 10 to the power negative pH will give you the concentration of the hydrogen ion. So log is just a way to say 10 to the power something. The opposite of 10 to the power something. Please, promise you, you won't die.
This is tense.
Okay. So what is the pH of water?
One. Jesus.
What is the pH of water? Let's do the mathematics. Get your calculators out. So pH is negative log of 10 to the power negative 7. It's 7. So the pH of water is 7. And as what do we classify water when its pH is 7?
Base.
Yes,
I know.
it's no neutral. So when something has a pH of 7, it is classified as neutral. But now we have learnt that in some reactions, water is a Lowry-Bronsted acid or a Lowry-Bronsted base. Does that change the pH of water? No. No. Okay? Not the water itself. Even though if you mix it with something, the mixture's pH will change. The water's pH.
So the water itself doesn't change.
The water alone, according to pH, is neutral.
But then the reaction.
So your idea of water as being neutral out there to people who do not do chemistry or physics, that is true. Water is neutral because its pH is 7. But water can act as an acid. It's an amphilite. It can act as a base. Because it can act as an acid does not make it its pH 4 or 5 or 2 or something like that. The fact that it can act as a base doesn't make its pH 7 or 8 or 9 or 10. Yes.
So, ma'am, when you get water, alkaline water, it's not the water that's pH is changed. It's what?
It's the mixture that's got a lower or higher pH. The things that were added to the mixture,
Ma'am?
to the water.
But like alkaline water has like a pH of 10. Is that like safe?
Yeah, I'm sure you've been surviving
Yeah,
it.
but ma'am, when
It's
you
the
do
salts
these-
in the water. I'm getting there. It's the salts in the water that will change its pH. I will discuss it still. Bear with me.
When you drink like water with a pH that high for the first time, your body reacts like weirdly to it. It's not like a normal feeling.
Oh.
You feel sick when you drink it.
Your special thing.
So it's when you drink hard water.
Hard water.
Yes.
No, ma'am, I'm talking
Hard
about
water is rich in minerals. You can buy the pH higher, the
That's what I'm
alkaline
saying,
water.
when you
I
drink
haven't,
that
it
water,
had no effect on me. To go for some pH calculations, we also need to go for some concentration calculations. So concentration calculations is part of your syllabus. pH calculations is not part of your grade 11 syllabus. So I'm going to mix the two. Okay? Let's take a strong acid.
Sulfuric acid.
No, let's take sulfuric acid. Okay. Sulfuric acid. That is a liquid. Pure sulfuric acid with no water mixed with it is a liquid.
Since like you're basically like teaching us and basically you see what you do most of the time is because like if you taught us then you test us. So since you're teaching us this, would you test us on it?
What do you think would they say if I would test you on this in a formal assessment?
Good teach.
You want me to test you?
No.
Yes.
It's one calculation.
Yeah, she'll be testing our knowledge.
It's one calculation. pH calculation.
Okay. Are you guys agreeing? It's one calculation.
It's one calculation. pH calculation.
No.
It's 3 marks.
No.
6%. And it's easy. No, I don't think it will do you harm. Okay. Right.
Look what you did.
Question.
Now I must study this.
Bro. Okay, fine. Yes, it was your question. You guys.
Decide on the volume of a solution that you want to make. 10.
18.
Okay.
18.
5.
18.
I have 100 milliliter volumetric flasks.
18.
So, no, 100 milliliters. I want to make a solution with a solution that's got a volume of 100 milliliters. So 100 milliliters is 0.1 cubic decimeter. Okay. Get the mass
So a cubic decimeter
of the sulfuric acid.
The mass.
Yes,
Is it more dense than water?
of course.
So let's say 150 grams.
150 grams.
Yeah.
Okay, so 150 grams.
Is this all given? You're giving us all of this, right?
Yes, I'm giving you this. What will the concentration of the sulfuric acid be?
10 to the -7.
No, don't give me rubbish now.
We're calculating that.
Concentration is calculated by taking the mass, dividing it by the molar mass, timesing it by the volume. What is the concentration of the sulfuric acid? So the mass you said I must use is 150 grams. The molar mass of sulfuric acid is twice 1 plus 32 plus 64, 98. And the volume you said is 0.1.
15,31.
15,31 mole per cubic decimeter. Now remember, pH is determined by the concentration of the hydrogens in the solution. Now I'm referring to hydrogen ions, but a hydrogen ion is also an oxonium ion. So whether they give it to you in terms of hydrogen ion concentration or oxonium ion concentration, it's exactly the same thing. because the moment you put the acid into the water, the ionization will take place and the hydrogens will be given to the water. So here we go. What will the concentration of the hydrogen ions be in the solution? Yes. Now here it is important to know that for one H2SO4 there are 2 hydrogen ions. So if you've got 1 mole of H2SO4, you'll have 2 moles of hydrogen ions. So the concentration ratio is 1 to 2. Concentration is directly proportional to moles. So what will the concentration of the hydrogen ions be?
30.62.
It will be twice 15.31, which is 30.62 mole per cubic decimeter. Yes.
So you not just say the mole is 1 to 2. So then why is the concentration now?
Also 1 to 2. If the moles are 1 to 2, the concentration will also be 1 to 2.
Is the concentration and the number of moles the same value?
No, not the same value.
So then why
The same, they are directly proportional. Concentration is directly proportional to moles.
But ma'am, right there we're calculating concentration, but then the same number of moles.
I don't know how many moles. If you want to know how many moles, take 150 and divide it by 98.
Okay, what?
This is the moles. The mass divided by molar mass will be the moles.
That's 1,53. Then you say 1,53. You say divide by the volume. And then you probably get the same answer for the hydrogen.
I didn't have to calculate. Lesego, sorry, I didn't have to calculate the moles. If I've got the concentration, I don't have to calculate the moles because I know concentration is directly proportional to moles. So if I've got the concentration of the sulfuric acid, I can calculate the concentration of the hydrogen ions by multiplying by 2 because the ratio between the mole acid and the mole hydrogen ion is 1 to 2.
Why is it 1 to 2?
Because it is diprotic. The sulfuric acid has 2 protons to give.
Ma'am, isn't it going to be 2 also for the sulfuric acid because it's H2?
No, 1 sulfuric acid has 2 hydrogen ions to give. So the ratio is 1 to 2.
So how did you know it was 2H plus?
Because when H2SO4 ionizes, it forms 2 hydrogen ions and the sulfate ion. It is diprotic.
I can give up 2. Oh, the 2. Okay.
Okay? Where? Yes, sorry. I'm just being a bit distracted. Okay. Now, what's the pH of this solution?
Negative 1 times 30.62. Negative 1,49.
That's very strong acid.
Yes, but you chose it to be 150 grams of sulfuric acid in 100 milliliters of water. So it's an extremely concentrated solution. I mean, we work with solutions that if it's 10 mole per cubic decimeter, it's extremely concentrated. We work with 0.15 mole per cubic decimeter concentrations.
So then what if we wish that's concentration, what would happen?
Don't worry, it's corrosive.
Remember, there's only 3 marks.
This calculation is 3 marks. One for the equation, pH equals negative log the concentration of H plus, which is given on the data sheet. One for that, and for the substitution, and one for that. This part is the grade 12 part. All the rest is grade 11.
Yeah, just keep the rest and leave that last one out.
No, man, put everything because that is
No, man, I wouldn't.
You say that in
It's not your argument, thank you. I'll decide.
I was going to ask, are the materials that are resistant to the corrosiveness of acids?
Usually glass is, and some plastics. So when you buy these chemicals, they either come in glass with a plastic lid, or they come in plastic with plastic lid.
What does it mean now that the pH is negative?
It means that it's an extremely strong acid. Okay? I'd like to move on.
Remember, I want to copy
And we dilute the solution.
Uh-oh.
So it's the same sulfuric
So
acid.
it is the concentrated sulfuric acid
Oh no. Can we do the 1%?
with a concentration of, what was it, 15.31 mole per cubic decimeter. So we will continue this then tomorrow. I need to give you some homework.
I'm just